What are some pairs of x and y that make this equation true? I have an equation here. We need to figure out some numbers of x and y that when I substitute them, when I put them in here, replace them, that it makes the equation true. Have a think about it for a little bit. Have you thought about it for a little bit? Maybe pause the video, have a deep think. I'll give you one and then I'll see if you can figure out some others. One of them is if x is 0, 2 times 0 plus 6 would equal 6. So if x is 0 and y is 6, then I would have, 2 times 0 plus 6. Yeah, that's 0 plus 6, which is 6, so that would work. Another one is if x is 1, I could have y being 4. 2 times 1 is 2, plus 4 really would give me 6. That would make that equation true. Another one, if x is 2, then I'd have 2 times 2, which is 4, plus, or maybe 2? Yeah, if x is 2 and y is 2, that also makes the equation true. There are actually infinitely many points that make this equation true. Infinitely many pairs of x and y. Let's plot these and have a look what it looks like on our Cartesian plane. The first point here is x being 0 and y being 6, which is up here. The next one, x is 1, y is 4, x is 2, y is 2. Interesting. Do you notice that this equation represents this line? This is the equation of this line. And by that, I mean that any point, I can check if any point lies on the line by checking if its x and y coordinates make the equation true. Let's look at some examples where we don't have a picture of the graph, where we need to figure out if a point follows an equation or not. As an example, I've just said the equation of a line will be true for all x, y points on that line. So if I have a line where the equation is y equals 5x plus 2, and I want to figure out if this point, x is 2, y is negative 3, if that point lies on the line, I can substitute. If x is 2, then, just to see where I got that from, that's x, and that's y. There we go. Cool. So if x is 2, let's see what happens. Let's see if we get a contradiction or not. Something impossible happening. If x is 2, then we know that y is 5x plus 2, right? So I can replace x with 2. Instead of x, I can write 2. Remember that between a number and a letter, there's an invisible times sign there. So that really means 5 times 2. I copy down the plus, I copy down the 2. I need to do, my BEDMAS, so I do multiplication first. 5 times 2 is 10, 10 plus 2 is 12. So apparently, if x is 2, then y would be 12. Hang on, but it's not, is it? It's negative 3. We have a contradiction. This cannot be true. So, that's not the same as negative 3. Do you like this symbol? It means not equals. So we got 12, but that's not negative 3. We were expecting negative 3, so it is not on the line. Cool, because we've got a contradiction. If it was on the line, the equation would be true. Let's try another one. If x is 3 and y is 17, does that point lie on the line? Well, if x is 3, again, y, given by this formula here, which is going to be 5 times x is 3, plus 2, I'll copy down the plus 2. 15 plus 2 is 17. And that is what I got for y up here. So it is on the line. In the next one here, we know that it lies on the line, and we want to find the y coordinate. So this might be useful if, there's a formula giving the dosage to give a patient, for example. You know the age of the patient, and you want to figure out how much to give them. So to find the y coordinate of the point, its x coordinate is 4. So if x is 4, the question tells us x is 4, Then let's write down the formula and just see what happens. We know x is 4 in this hypothetical scenario, so I'll replace x with 4. I'm going to be careful to write the entire equation, therefore y equals. Mainly because this one will need us to write the whole equation. So we'll get in that habit. Anyway, 5 times 4 is 20. 20 plus 2 is 22. So if the x-coordinate is 4, then the y-coordinate would be 22. The next question looks very similar. In fact, we're going to solve it the same way, but actually it's entirely backwards. It still says, we know a point lies on the line, so the equation will be true. Its y-coordinate is 4. Find the x-coordinate. Do you see that that's backwards to this one? So if its y-coordinate is 4, so if y equals 4, then let's just see what x would be. We'll write down the formula exactly as it is in the question, and we're going to replace y with 4. So instead of y, I'll write 4. Do you notice that everything else stayed the same? And I've got a therefore in front. Now we can use our tricks from linear equations to solve it. If you've forgotten about this, just go back to my very early linear equations videos. I'll try to remember to put a link in the description. Plus 2 here can turn into negative 2 on the other side. The 5x stays there, the 4 stays there, the equals stays in the middle. 4 take 2 is 2 equals 5x. Can divide by 5. 2 divided by 5 equals x. Therefore, x equals 2 over 5. The reason I've skimmed through this, again, is because if you're not sure about this, go back to the linear equation videos, the early ones, where I show you how to move terms around. I have done it slightly differently here. Normally I say numbers to the right and letter terms to the left, but that's okay, because I flipped it in the end. I ended up with 2 over 5 equals x, so the answer is x equals 2 over 5. I don't think I would have ever guessed that, would you? If you had to guess a number for x to put in here so that the answer would be 4, would you have guessed 2 over 5? Maybe not. So that's why having a good solid strategy, an algebraic strategy, is helpful when the answer is too tricky to guess. Or if you need to tell a computer to do it as well. All right, so I hope this has been helpful. I will see you next time. Bye, everyone.